All right. Sorry I couldn't be there today, but I wanted to provide you with a little instruction anyway, so we're doing a little video here. So um, this is the worksheet for today on given proving lines parallel. This is module 1, lesson 10. All right. So let's get right into it. So today we're going to be talking about how to prove lines parallel or using lines parallel. So if we are trying to show that two lines are parallel, then what we need to do is have one of these angle relationships pop up. We either need to show the corresponding angles are congruent, alternate interior angles are congruent, alternate exterior angles are congruent, the consecutive or the angles on the same side of the transversal, but interior angles are supplementary, or even the same side consecutive exterior angles are supplementary. All right. If I get one of these 6 things to happen, it's enough to say that the lines are parallel. So, and vice versa, if I know the lines are parallel or they're given to me, then I can also prove that all of these things happen because of it. So, if I'm given that the lines are parallel, or I already know that, I can use it to show these by this statement right here. If the parallel lines are if two lines are parallel, I'll fix this, huh? So if two lines are parallel, then we just insert one of these angle relationships right there. Okay, the corresponding angle is congruent, or alternate interior angle is congruent, whatever one you're trying to show. And if you need to prove that they're parallel, we just do the converse. Remember, we flip them. So if the corresponding angles are congruent, then the lines are parallel. Okay, we just flip them around. So just a little quick practice. All right, a little cheat chart for ourselves. So statements. Want it ready for the magic? Here comes the magic. Reasons, right? Okay, and then we're going to do their givens. So we know that angle 1 is congruent to angle 2. So angle 1 is congruent to angle 2. And we are going to write that it's given. And we want to prove that these two lines are parallel. So do we have enough? Do we have one of these things happening? And the answer is yes, right? These two angles are corresponding. So then the second thing I can say, as soon as I get those angle relationships to happen, I can say that L is parallel to M. And the reason it's going to be is just if corresponding angles are congruent, the lines are parallel. Okay, that's it. All right, and we can flip it. So what happens if I'm given that the lines are parallel, okay, and I want to show that those angles are congruent? So how do we go about doing that? So first you're going to do your T-chart, and then your givens, boom, right? And then how do we show that this is congruent to this? Well, if we know the lines are parallel, right, then all those angle relationships are going to be true. So 2 and 3, right, are alternate and exterior. So we're just going to say, okay, we have enough. So angle 2 is congruent to angle 3. And then we just flip this around. We just say if the lines are parallel, alternate exterior angles are congruent. And that's it. Okay? So if insert angle pair here or whatever, congruent supplementary, lines are parallel, that's when I'm proving. And if I'm using, it's if the lines are parallel, then insert your angle relationship. Okay, so let's do a couple proofs here with this. A couple practice ones. All right, so take a minute. All right, fill in the statements and reasons for yourself in the givens. Right, so go. Boom. All right, now, when we do a proof, the first thing we're going to do is we're going to look at our givens, and we're going to look for anything that we know is congruent already. So I know right here that 1 is congruent to 4. And I want to go to my diagram and I want to mark that down. So when I'm looking at my diagram, that's something I'm going to notice, okay? And I can use that visually to see what's happening. Okay, now I want to go back over here and I'm going to look for key words in the given. And so my key vocab word is bisect, okay? So remember, what does bisect mean? Okay, so bisect means we're going to cut into two equal parts. And then what are we cutting? So if I cut a watermelon, right? Or I bisect a watermelon, what gets cut? Okay, the watermelon. So if QT bisects angle PQRS, what's going to get cut? The angle PQRS. So here's PQRS right here. And if I cut it in half, all right, then that means that I'm going to get two equal angles. It's going to be angle 1 and angle 2. These two angles are going to be equal. Okay, so for step 2, we're going to say that angle 1 is congruent to angle 2. And the reason we knew that was because of this word right here, bisects. So what does an angle bisector do, right? And we can just say angle bisector cuts angle into two congruent angles. You can just explain it in words, okay? You can even just put bisector. Bisector cuts an angle into two congruent parts, right? That's it. We have that one. So now I know that 1 is congruent to 2. And keep in mind, I already knew that 1 was congruent to 4. So what do we do when these two things are equal to each other? Okay, we're equal to the same thing. 1 is 2, 1 is also 4. So that means, if 1 is congruent to 2, and 1 is the same as 4, what does it tell you about these two guys? Okay, and hopefully you're thinking that they're equal. And also, if you look at the diagram, what's going on here? Are you seeing the Z? So if 2 and 4 are equal, those are right alternate interior angles. Now that's enough to show that those two lines are parallel. So the first step for step 3 we need to do, okay, is say that angle 2 is congruent to angle 4. And this is formally known as the transitive property. So the transitive property just says that if I have two things, right, that are equal to the same amount, like A is equal to B and C is equal to B, then these two things that are both equal to B have to be equal. Okay, that's the transitive property. We use the word substitution for this, but on the Regents exam it's come up where they've asked a multiple choice question and the transitive property has been the answer. So I just want you to remember what transitive means. If these two angles, 2 and 4, are both equal to the same thing, then they have to be equal to each other. Okay? And now, have we proven one of these 6 angle relationships, these 5 angle relationships? And the answer is yes, we have, right? We've shown the alternate interior. So that means we have enough to say that the lines are parallel. Okay? And then we're just going to write down if the alternate interior angles are congruent, the lines are parallel. And there you go. That's it. All right. Number 4. Okay, let's take a look at another one. So we know that angle 1 is congruent to angle 2. And we know that angle 3 is congruent to angle 1. So that's the given. So let's fill in the givens first. Ready to go? Meet you. All right. And what we want to do now, okay, is show that these are parallel. So take a second, pause if you need to, fill in the givens. Okay. By the way, for proof, you have to put the givens down or you will lose a point, because these are what you're using to justify your proof. So if you're missing your givens, right, that's our ingredients, you can't make your dinner. You can't finish the proof if you don't have the givens. Okay, so we got the givens down. So remember, 1 is congruent to 2, 3 is congruent to 1. So what do we know about 2 and 3 here? And hopefully you're going to say that they're congruent to each other, right? And then remember, that's the transitive property. Okay, so now if 3 is congruent to 2, what does it tell us about B, C, and G, F? Hopefully you're seeing the relationship there. If we slide this up, they're going to be in the same position, right? And so that's enough to show that those two lines are parallel. And so this is going to be if, insert vocab word, corresponding angles are congruent, the lines are parallel. All right. Now, if you go look at in your book, stick your module book out here, and let's go to page 53. Okay, and you're going to see this diagram right here. And so what we're going to talk about is Euclid's parallel postulate. So Euclid is the guy that actually kind of like discovered / created / put down in words the geometry that we're learning right now. One of 3 geometries, by the way. So Euclid came up with one of his postulates. This is something he assumed was true, and later on was proved correct. And he said that given any straight line and any point not on that line, so straight line, point not on it, okay, there exists one and only one straight line which can pass through that point, okay, and will be parallel, right? That will never intersect that given line, the line we started with. Meaning there's only one line we can draw that's parallel to the original line through a point not on the line. Okay? So we're going to use that today. And that's kind of what we've been doing before with the lines we've been drawing. We've added all of those auxiliary lines. So on page 53 we see this drawing. Okay? And in the figure, right, A, B, and D, E are parallel. Okay? So we've got A, B, D, E parallel. I got BC and EF parallel, and I want to show that these 2 angles are congruent. Right now, I really can't do that. But if I take a straight edge and I extend these 2 lines, BC out, and I extend ED out, we'll see that eventually they'll cross, okay? And they'll meet right here, all right? And we'll label this angle, angle 1. And so what we want to do is we want to use this angle to our advantage here. All right, so extend BE and ED, so it hits, okay? And now can we figure out how to use those angles? And if you look right back here, these 2 lines are parallel, right? So this line is going to create this crazy long Z, right, with this line, and I get this crazy long Z here, which means that this angle is actually equal to B, right? And remember that this angle, right, was parallel. These 2 lines are parallel. So I get another crazy long looking Z over here that looks like this. And so now these 2 angles are equal. Okay? So the proof we're going to need to start with is our t-chart, right? So ready? We'll race. Race it, go. All right. And if you need to, pause and catch up. Okay? Step on some tomatoes and catch up here. All right. So we know that these lines are parallel. Now, what we want to do is we want to extend those lines out, okay? And so we're basically going to say here is just extend, okay, BC and DF until they intersect. And really, all we're going to say here, okay, is just this line, extensions of parallel lines are parallel, okay? Meaning if we just extend these lines out, they're still going to stay parallel here, okay? So these lines are going to be parallel, those lines are going to be parallel, but eventually these 2 lines which aren't parallel are going to meet, okay? So we're keeping all the parallel parts here. Sounds a little weird, but that's what we need to do the proof. All right, so part 3, right? And we'll say at angle 1. We'll add that on. So we named it here. It's in the given here. It's in the proof statement. All right, so what do we know? Now we know that this is parallel to this. So angle B is congruent to angle 1. Okay, remember the reason. If the lines are parallel, what happens? Remember the Z, that's the alternate interior angles are congruent. And likewise, 1 is going to be congruent to E, and it's the same reason, so we'll just add it on. And so can we get B and E congruent from this? Yes, we can, because we got them both equal to 1. So we can use our transitive property again. All right, and so that proof is done. We're done because we got the proof statement. All right. All right, let's do one more, and then I'm going to ask you guys to finish these other ones for homework here, okay? So take a look at number 2. This is also on the next page, so if you turn, actually, that's this one. All right, so we talked about in the previous lesson, right, that we were able to use some deductive reasoning. We're able to draw in and extend line segments, okay, or draw some auxiliary lines, and they helped us create new angles that we could use to solve a problem. So this question actually has 2 ways to do it. Can you think of 2 lines that you could possibly draw here that are going to help us solve this question? One should be pretty easy because we've done it before. So think if you can think of it. And I'm going to draw it in and let's see if you get it right. All right. And hopefully that's the line you drew right here. Okay. So remember, we cut this angle and we're going to label these angles as 1 and 2. All right. And if you want, we'll call this L. And so by doing this, right, remember what we've done. We can now use this angle X, okay, and show that it's congruent to 1, and use angle Y to 2, and then we can just use 1 and 2 to make Z, and then substitute in, and we'll get here, okay? So let's do it real quick. So we're going to do a T-chart, okay? So we have AB parallel to CD, and that's given. All right, so 2, we're going to say draw line L, okay, through angle Z. And the reason for this is Euclid's parallel postulate, okay? So we can just write down Euclid's parallel postulate. We're not going to write out that crazy long thing. We're just going to put that, right? Through one point, not on a line, there's only one line that's parallel to it, okay, that goes through that point. That's what the postulate says. So that's how we're drawing it. All right. Now, remember, this angle, drop it down right here, will match on top of that. So we know angle 1 is congruent to angle X. Remember, these are called corresponding angles. So if the 2 lines are parallel, because that's what we know already, that these lines are parallel, then the corresponding angles are congruent. All right, and likewise, we can use the same reason down here. So angle 2 is congruent to angle Y. And now we got to somehow get this, right? So what do we know that Z is equal to from the drawing? And hopefully you're recognizing right here, right? That angle Z is actually equal to angle 1 plus angle 2. And remember what that's called? We add 2 small angles, we get a bigger one. That's the angle addition property. All right. And then the last step is just to plug in. So instead of 1, we're going to write X. Instead of 2, we're going to write Y. Now, remember, we're not setting equal here. So this is actually substitution. And then we're done. Okay? The other way to do this, all right, is, and this is the other way you can get this done. So we got this drawn. Okay? There's X. There's Y. This is Z. Is actually to extend this down this way. So we're going to extend this line down in this direction, okay? And so what we want to do now is basically use our triangle, right? This angle here, okay, because these lines are parallel, right? This line is parallel to this line. This angle and this angle are in the same position. These are corresponding. So this is essentially X as well, okay? And remember, these angles are vertical, so this is essentially Y. And then this is our exterior angle theorem, right? So angle Z is going to equal angle X plus angle Y. So you would literally do, right, extend this line out. So extensions of parallel lines are parallel, okay? Then you're going to say that angle X is congruent to, and you can call this 1, okay? And 2, angle 1, and you're going to say two lines are parallel, the corresponding angles are congruent, we have vertical angles are equal, then we're going to do Z is equal to angle 1, Z equals Z, angle 1 plus angle 2. That's the exterior angle theorem, and then substitution. All right, let's do one more together, and I'll leave you for your homework. Thanks for following along so far, guys. Let's take a look at number 1 here. So, in the figure at right, we know that AB is parallel to CD, and BC is parallel to DE. So, do we need an auxiliary line here is the question. Remember our Z's, right? We want to show that ABC, which is this guy, is equal to CDE, which is this guy. Okay, can we get that those two are equal? And all remember, if you see parallel lines, look for your Z, right? So I should be able to show that this is congruent to this, right? And there's another Z right here. Okay? And I should be able to get that this is congruent to this, and then there's our link. All right? So put down our statements and reasons, the givens. I'm going to pause it, trying to save some time. All right. So then we're going to do for 2, okay, we want to say that angle B, right, I can call it B because it's the only angle there, is congruent to angle C, okay, and that's going to be if the two lines are parallel, and remember this is the Z, so alternate interior angles are congruent. All right, and likewise there's another Z here, so angle D is congruent to angle C, and then all we want to do, this is angle B and angle D, so all we got to do is just use that transitive property again, right? Just substitute those out, and then we're done. So in this case, we didn't need an auxiliary line. All right. Okay, last but not least, and then I'm going to ask you guys to finish the rest of this for homework, okay? We got the next guy here. So, look in the figure right. We know that AB is parallel to ZE, so once again, T-chart. I should say CD, and BC is parallel to DE. So this is something that I know, so I'm going to label it on my diagram. So labeled, good. And now I got to somehow get that B plus D is equal to 180. So I need to get like a relationship. I need something. I need an auxiliary line, right? So what I want to do is extend, see if you can think about this. How can I help? How would extending this line help me out here, okay? And that's not the only line we need to extend. What other line do you think we need to make longer? Think about it. Talk to that person next to you. What do you think? What you thinking? Oh, you're right. Yeah, AB, right? If we send this one over here in this direction, okay? Now, think about what angle this B is going to be equal. Angle B is going to equal over here, okay? Got it? Is it this one? No, I was playing. It's this one right here. So this is also going to be like angle B. We'll call it B prime, right? Okay? And now how are these two related? That's right. Consecutive interior, right? Same side interior. So they're supplementary. All right, so that's the plan. So 1, we did the givens. 2, right, we extended the lines. So extend AB and DE until they meet at, and let's give this a point. We'll call this F because we're fancy, right? Okay. And if you wanted to explain this, the way Euclid would have said it is any two lines intersect at a point. So he would have said something like that. So let's write that down instead. Any two lines intersect at a point. All right. And actually, we should say any two non-parallel lines, right? Because they're parallel, they won't. So any two non-parallel lines are going to intersect at a point. All right, that's this guy right here. If you want to say extensions of parallel lines are still parallel, totally fine. We're extending this line out, that line, so these are staying parallel as we go along. Okay, 3. Now we're going to say this angle, right? So instead of calling it B prime, we now can call it BFE. So we're going to say angle B is congruent to angle BFE, okay? And that's going to be if the lines are parallel, right? These are corresponding. Angles are congruent, all right? And then, remember, how are these two related, right? Those are supplementary. So angle D plus angle BFE is equal to 180. And that's our same start if the lines are parallel, consecutive, or same side. Angles are supplementary. Okay? And the last step, see if you guys can finish it off. Waiting for you. And we're going to use substitution here instead of transitive because we're plugging in instead of setting it equal, okay? All right, and then see if you can try these guys down here, right? And I will see you guys on Monday. Remember, review day tomorrow, okay? So I'll leave you the review sheet to work on tomorrow. Finish that for homework over the weekend, all right? I'll send the review answers to you guys tomorrow to check out, okay? And I'll also send you a video of the review sheet answers. All right, guys, thanks for sticking along with me. Appreciate you guys. Appreciate your effort so far. We'll see you on Monday.